Okay, this is solution to C3, January 2014, question 8. So it's a differentiating trig question. It says, consider the function y is equal to cosec squared x, find d2y by dx squared, giving our answer in terms of cosec. And this is an 8-mark question. So first of all, what is given in your formula booklet? You're told, it's not written out in this form, but you're told if you differentiate tan, you get sec squared, and you're also importantly told if you differentiate cosec, you get minus cosec cot. So use that. So only if you're asked to do something like this, you must use the formula booklet unless they tell you to do it. They're asking you to do it show by first principles or something like that. You won't have to do it this way. So first of all, write down what you've got. So this is our 8 part 1. Y is equal to cosec squared x. So if you differentiate that first of all, let's write that as it's cosec x all squared. So what we've got is a function of a function. So to differentiate this, differentiate with respect to the power, you're going to have 2 cosec x now to the power of 1, and then differentiate inside the bracket, you're going to have minus cosec x times cot x. And again, just check that. Differentiate cosec, you get minus cosec x cot x. So when you tidy that up, you're going to have 2 cosec squared x times cot x. So that's your dy by dx. Oh, minus in there as well. Now what we want to do is we've got our dy by dx. We want to get to d2y by dx squared. So d2y by dx squared, we're going to have to differentiate this thing again. This is a product, and it's a fairly tricky product, so I'm going to write it out again. I'm going to use my product rule to do this. So I'm going to say my u is equal to, and I'll call it minus 2 cosec squared x. My v is equal to cot of x, and I'm going to have to work out what du by dx is. I'm going to have to work out what dv by dx is. So du by dx, and now we have just done this up above here. We've shown if you differentiate cosec squared, I get minus 2 cosec squared cot x. So if I differentiate minus 2 cosec squared, I'll get plus 4 cosec squared x cot x. Okay, so how I got that again, I differentiate this thing, and what I got was this. So if I differentiate this thing, which is minus 2 times as big, I'm going to get something which is minus 2 times as big. My answer is going to be 2 times as big as the first result. Okay, so that's that one done fairly easily. And differentiate cot, that's given for us as well. If you differentiate cot, you get minus cosec squared of x. Right, what we do, our product rule then, is going to be then our d2y by dx squared is going to be equal to our v du by dx plus my u dv by dx. So it is going to be equal to, it's going to be cot x was my v, and my du by dx that we've just worked out is 4 cosec squared x cot of x, and then my u was minus 2 cosec squared x, and then my dv is again is going to be minus cosec squared of x. So if you multiply this out, you're going to have 4 cosec squared of x times cot squared of x, and over here you're going to have plus 2 cosec to the power of 4 of x. Okay, now I think that's probably it done. Let's read the question again. It says, find d2y by x squared, giving your answer in terms of cosec. So we've got a mixture of cosec and cot. So we've got to change this cot squared. Okay, now we've got 3 wee trig identities, which come from our sine squared plus cos squared. Sine squared plus cos squared x is equal to 1. And if you divide those through by sine squared, what you're going to get is sine squared divided by sine squared is 1. Cos squared divided by sine squared is, well, 1 over tan squared, which is going to be cot squared of x. And then 1 divided by sine squared is cosec squared of x. So here we could rearrange this to get cot squared is equal to cosec squared of x minus 1. And this is what we're going to want to put in here. So instead of writing cot squared up above, in here, we're going to change how cot squared looks. So cot squared, we're now going to write as cosec squared minus 1. So this whole thing becomes 4 cosec squared of x times cosec squared minus 1. And then over here, we had our 2 times cosec to the power of 4 of x. And then that can tidy up. That's going to be multiplied. You're going to have 4 cosec to the power of 4 of x minus 4 cosec squared of x, and plus 2 times cosec to the power of 4 of x. And then tie that all up, you're going to have 6 cosec to the power of 4 of x minus 4 cosec squared of x. Okay, and so that's that bit done. That should be okay for that. Let me get rid of that. That's a real mess there. Apologies. Run that over here. Okay, so that's what you've got. So let's just go through that again. That was our dy by dx squared, and we worked out our v. We worked out our v, and our v was equal to cot. Our u was equal to minus cosec squared, and then you differentiate your u to get du by dx, which was 4 cosec squared and then cot, and your v differentiated to give you minus cosec squared, and then you have to change your cot squared to be in terms of cosec. Okay, last part of that question says, hence find the turning points of the curve. Right, not nice at all. Hence find the turning points of the curve. So the turning points, so just because you're using hard trig stuff doesn't mean the turning point rules of it change. For the turning points, for TPs, what you need to do is you need to put your dy by dx equal to 0. So it just says find the turning points. It doesn't say, it does say and determine their nature, so we've got to do a whole shebang. So you've got to put your dy by dx equal to 0, and your dy by dx was, it was equal to minus cosec squared x cot x. So we've got to put that equal to 0, which is not going to be nice at all. So if we put that equal to 0, let's see. So let's tidy that up a wee bit and see what that looks like. So you've got minus 2 cosec is going to be sine squared on the bottom line. Your cot is the same as cos x over sine x. So that's what you have is equal to 0. So this looks really difficult. So you've got minus 2 cos x on the top line, and you've got sine cubed on the bottom line is equal to 0. Now to put a fraction equal to 0, all you actually have to do is put the numerator equal to 0. So here, just put minus 2 cos x equal to 0, which is the same as just cos x equals 0. And you should know then that cos is equal to 0. Cos is equal to 0 at 90 degrees. So cos is equal to 0 at 90 degrees. So x is equal to 90 degrees. And what is our range? Have we got a range or anything? Yep, and 2 pi. So, oops, sorry, it's in radians, apologies, it's in radians. So if it's in radians, write that as pi over 2. And then let's just think about where 90 degrees is in your cast diagram. So 90 degrees would be here, which is the same as 2 pi. So cos is equal to 0 up here. Cos is also going to be equal to 0 down here, which is going to be either 270 degrees or 3 pi over 2. And that's going to be radians. I should have said that's going to be radians. All right. So there's where it is equal to 0. But you also need to find the turning points on the curve, and you need to find their nature. So we'll say when x is equal to pi over 2, you want to find your original thing, remember, was cosec squared. So y is going to be equal to cosec squared of pi over 2. So that is the same. How you would do that in your calculator, that's 1 over sine squared of pi over 2. So how you would do that in your calculator, you do 1 divided by brackets, and then it was sine of your pi over 2, and then square that, please. So that whole thing gets squared. So 1 divided by sine of pi over 2, and then that gets squared, and then that just gives you 1. So y is equal to 1. So you've got a point which is pi over 2, 1. And also, we'll say when x is equal to 3 pi over 2, y is going to be equal to cosec squared of 3 pi over 2. So that is going to be equal to 1 over the sine squared of 3 pi over 2, and go through that same process on your calculator to get that. So that's going to be, and I can just go in and edit that now on my calculator. So I've got that thing written out, the formula there written out in my calculator. Go back in and edit to save yourself a wee bit of time. Change your pi over 2, delete it, and change it to 3 pi over 2. And I've done that, and I've got 1 again. So that's my 2 points, my 2 turning points in. I've got pi over 2, 1, and 3 pi over 2, 1. And then what we want to do is find their nature. So to find their nature, you've got to sub them in. So just say when x is equal to pi over 2, our whole horrendous looking d2y by dx squared, so what was it? 6 cosec to the power of 4x minus 4 cosec squared. So my d2y by dx squared is going to be equal to 6 cosec to the power of 4 of pi over 2 minus, and I've forgotten already, minus 4 cosec squared of pi over 2. So fire that into your calculator. Again, that's not nice to do. So that's going to be 6 over sine to the power of 4 of pi over 2 minus 4 over sine squared of pi over 2. So do this nicely on your calculator so that you can use this, because you're going to have to do this for the other turning point, remember. So fraction, but I'll use my fraction button here, 6 on the top, and then on bottom line, I've got brackets. I've got sine of, what was it, pi over 2. And then that was to the power of 4 on the bottom line. And then take away, and my fraction button, 4, bottom line, I've got, I'll do bracket, and then I'll do my sine. And then that bit is being squared. Press equals. I get bang on 2. That seems too nice, too good to be true. So I get 2, which is greater than 0. Therefore, that tells me that my point, which was pi over 2, 1, is a minimum turning point. So remember, d2y by x squared, your test function, if it's positive, then it's going to be a minimum turning point. And the other thing, say when x is equal to 3 pi over 2, your d2y by dx squared is going to be equal to, so it's the same thing, it's going to be 6 cosec to the power of 4, 3 pi over 2, minus 4 cosec squared of 3 pi over 2. And again, go in and delete that. I'll not have to show the working out for this time, so we can go in and delete. Change your pi over 2 to 3 pi over 2 now. So I've just gone in and done that, and I got 2 again. So I got 2 again, which is greater than 0. Therefore, that tells you that 3 pi over 2 and then 1 is, again, a minimum turning point. And that's us done.